Inflation ended very soon after it began, when its energy was frozen into tiny objects called particles. The universe was still expanding, and so this universe, which was filled with particles and it was expanding, is what we now call the Big Bang. There were many different types of particles formed, and I want to talk about those which will be important later in the story. So they will be quarks, protons, neutrons, electrons, and radiation. So, quarks. During the first few nanoseconds after the Big Bang, the universe was still very hot, and it contained a soup, a vast array of quarks and other particles which stuck the quarks together, and we'll talk about forces between particles in the next episode. But these particles which glued quarks were called gluons. Because the universe was very hot, the quarks were moving around very quickly, and the gluons were not strong enough to hold them together, so the quarks moved individually. And this was the last time, at this very early period in the universe, the last time when quarks were individual and free, until mankind came along and built particle accelerators and was able to recreate this soup of quarks and gluons, and we're still investigating it today. So there are 6 types of quark: the up and the down, and we'll meet those when we talk about particles which form the universe today. There are also the strange and the charm, and the top and the bottom, and some of these we never meet except in particle accelerators. Quarks hold electrical charge, but it is either 1/3 or 2/3 of the charge on the particles that we know today, such as the proton. As the universe expanded, it cooled, and the quarks moved more slowly. The gluons were now able to stick the quarks together. So, for example, 3 quarks were able to stick together to make a single particle. There were 2 up quarks and 1 down quark. Now, scientists say that quarks have colour. This is simply a convenient way of describing an attribute which quarks have, which governs how they stick together. They say that each quark is either red, blue or green, and in order to stick together to make a larger particle, one of these heavy particles made of 3 quarks, you need 1 red, 1 blue and 1 green. One of the particles which was created by the sticking together of quarks is called a proton, and protons have a positive electric charge, and the 3 quarks are hidden inside them, and today we never see free quarks in the universe except, as I say, in powerful particle accelerators. As we will see in a later episode, protons form the central part of the atoms which we find around us, the central part being called the nucleus, and protons are part of the nucleus of atoms. Another particle which was created when quarks stuck together are called neutrons. The neutrons contain 2 down quarks and 1 up quark. They have no electrical charge and hence their name. They also are contained in the nucleus of many of the atoms around us. But in the young universe, the protons and neutrons and other particles were moving too quickly for them to stick together. So at that stage, there were no nuclei, no particles stuck together, except for the quarks sticking together to make protons and neutrons. Other particles in the young universe were called electrons, and these are very common in the universe today, as we will see. They are very light, and therefore their cloud-like nature is very apparent. Again, all particles have got this cloud-like nature, but with electrons it's very clear. And the density of the cloud determines the probability of finding the particle, the electron, at that point in space. The mathematics of this is governed by the part of physics called quantum mechanics. Electrons carry a negative electric charge. Contrast that with the protons, which carry a positive electric charge. Electrons are the particles which carry electricity in wires, and we will see later on that as the universe cooled, the electrons were able to stick to protons to make atoms, and they formed an outer shell because they're much bigger. These cloudy electrons are much bigger than the protons. The final type of particle or object I want to talk about is radiation. And radiation is a wave that includes both electric and magnetic fields. And examples of radiation are light, X-rays, radio waves, and there are many others. And radiation moves at the speed of light. Different types of radiation can have different wavelengths, and shorter waves carry more energy. And radiation can also behave like particles when it is called a photon. So thank you for watching, and if you like this story, you might be interested in my website historyoftheuniverse.com. Thank you. The last type of energy I want to talk about is radiation. And radiation is a wave which includes both electric and magnetic fields. Examples of radiation are light and X-rays, radio waves, and there are many others. It moves at the speed of light, not surprisingly, because that's one of the examples. And the shorter the wavelength, the more energy they carry. So X-rays are very short waves. These waves can also behave as particles when they're called photons. And it turns out that all particles sometimes behave as waves. Thank you for watching, and if you like this story, you might like my website historyoftheuniverse.com, which covers everything I talk about in more detail.